It is really great to be here. I'm happy that I made it in spite of the Lufthansa strike. This is, I think, now my third VMUG in Italy ever. I love the VMUGs. I love the VMUG leaders. We should give them a round of applause for. I remember the first time that I saw VMware Workstation, like 10 years ago, and I was like, this is the coolest thing ever. And then I saw GSX, and I'm like, this is slightly less cool. And then I saw ESX, and I'm like, this is freaking awesome, right? And the thing that struck me then is immediately I found this community of people, right, who were really into it like I was. And ever since then, I've been fascinated by how much the VMware community works on the community. And actually, I think what's interesting is that as new technologies come on the market, some from VMware, some from EMC, but many from other places, all over the place, lots of cool stuff. It's interesting to see how everybody is now realizing how important community is for technology adoption. So it's great to be here. I love supporting the VMUGs in any way I can. So again, thank you for having me. A quick introduction, my name is Chad Sakac. My official job is I lead all of the customer-facing SEs, all of the field customer nerds in the world. So I suppose that makes me the king of the nerds. And I say that with pride, right? As technologists, we should be proud of being fascinated by technology. That means that I get to see and talk with lots of customers. The biggest of the big, the smallest of the small. Yesterday, as I'm just getting ready to come here to Italy, I was meeting with Vodafone as an example. But then later on that day, I met with a very small local retailer in South Carolina via telepresence, right? So all customers are interesting. All customers are beautiful. They're like little snowflakes, They're all special in their own way, right? In that role, I get to see and have lots of conversations with people, and I'm finding that these three topics are topics that are furiously debated and discussed, and there's lots of opinion. And by the way, I have an opinion, but it doesn't mean that my opinion is right. So I want to share with you my opinion, and based on what I see, and hopefully maybe have some dialogue. And then afterwards, we're going to have a panel, which is a good segue, because the panel will allow us to continue the dialogue and answer questions that you folks might have. Just one warning in advance. I'm playing with a new toy, which is a Surface Book. It's really cool hardware, really cool, extremely buggy software. So I'm like 90% sure there's going to be a crash somewhere in the middle of this, so that's intentional. So first things first, a huge thank you to everybody here, from me to you. Just out of curiosity, who here is an EMC customer? Just by show of hands. So thank you very much for being our customers. We know that it's our job to support you through thick and through thin, through good and through bad, right? Technologies break, things aren't perfect, and we always have to be partners with you through good and through bad, so thank you. And I presume that everybody here is a VMware customer, right? So thank you for being VMware customers. Anyone here a Pivotal customer, just out of curiosity? I would wager that many of you actually are, but you don't know it. So if you use TC Server, if you use Spring or Spring Boot, in your development arms, it's crazy. I mean, we talk about, Duncan, how many vSAN customers are there now? 23,000? I was like, whoa, that was really good in Q3. So roughly around 2,000 customers. It's doing great. It's got lots of positive momentum. We'll talk about that in the SDS dialogue. Technologies like Spring Boot that we don't think about because we tend to be very focused on the infrastructure get downloaded 1.3 million times a day, right? So there's a whole universe above and around the world that we focus on in the domain of infrastructure. So it's always interesting to talk to people. So one thing I would be remiss if I didn't say something. Has anyone heard about this? So I don't want to spend a lot of time on it. I did dress in my EMC Dell blue just to fit into the whole scene here. But just so everybody understands this, There's a lot of stuff going on in the industry. We're going to be entering into a period of a lot of consolidation because between everything that VMware is doing, everything that's going on in the industry around convergence, converged and hyper-converged models, non-hyper-converged models, but there's commoditization and simplification of the whole IaaS stack. Like if you take a step way out, right, and the public clouds are kind of demonstrating that people want to simplify and commoditize all of that stuff down, and the value will be less and less in the ingredients and more in the totality. That means, by definition, we are entering into an era of consolidation. That's the first thing to think about this. The second thing is it is the biggest merger in high-tech history, $67 billion. But you guys need to all understand it is not Michael's intent, it's none of the executive team's intent, and I can say this with authority, in spite of the fact that I'm the king of the nerds, I am part of the executive staff. We need to create a new organization that is nimble and focused. So what you should expect is to see a PC and consumers business and an enterprise systems business. VMware will continue to do their thing. A lot of VMware's mojo comes from their autonomy and independence and open ecosystem. Same thing with Pivotal, et cetera, et cetera. And then the last thing that I want to just put in your minds that is an interesting thing, watch this. I have no idea how you're going to answer this. Do you think that over the next 5 years, more and more IT is going to get consumed in a as-you-use-it model, in a utility economic model? Who says there will be more like that over the next 5 years? Who says that they think it'll be the same as it is now? And who thinks that people will buy more capital than they do today? In other words, everyone in the room agrees that there will be more and more utility economic models that exist in the market. Have any of you ever had a salesperson push really hard to buy something at the end of a quarter? Anyone? It never happens, right? So why do they do that? They do that because a public company has got a responsibility to the market to basically deliver earnings in a 3-month period. Right? That's it. The market doesn't care whether if you as a customer said, you know what, actually I really don't need this now. I'll need it in 6 months. What will the rep do? No, you got to buy it now. You really, I'll discount. So that what happens in publicly traded companies is a lot of weird, stupid stuff to try to hit a quarterly cycle. And you see this as customers. It's kind of frustrating for us as the vendor ecosystem, but it's the nature of things. We will be the largest private company, which means that you won't get the end of quarter push. If you said, I don't want this as capital, I want to have it as a utility, we'll say, great. But we can't do that as a private company. Do you understand that? So those are the 3 big ideas I want you to take. Yes, it's a massive merger of technology giants, and we hope that we can continue to serve you better. It's not going to be one giant monstrous company because that would be bad. It's a set of focused companies that are fast and nimble. And the ability to be a private company means that we can actually serve the market better in a period of very large disruption. So just wanted to put that out there. Okay. Software-defined storage, first debate topic. So this has hit the marketing buzzword stupid level, right? Just stupid. And I often am asked, is this a real idea? Does this actually have a real definition? Steve Herod, who was the CTO of VMware at one point, his definition was the best I ever saw, and I've stolen it, and I've used it ever since, and I think it's right. The technical what are 3 things. Number 1, decoupling control from the thing that does the work. So today, when you tell a network switch to configure a VLAN, how do you do it? You usually SSH into the switch, and you tell the switch, configure this VLAN on this port. In other words, you tell the thing that's doing the work directly. Control is coupled with the switch. If you were using a software-defined network, like NSX, you could configure VLANs without needing to touch the thing that forwards Ethernet frames. Does that make sense? How do you configure a LUN on a storage array? You tell the array what to do. right? In other words, and if you automated it, your automation would now be coupled to that particular thing, right? So abstraction of control is the first principle of software-defined. The second principle, which is the thing that people tend to focus on, which is the data plane, the data services, where you can implement them as software that is not hardware dependent. So you could run on any hardware, do it, because generally that will make you more flexible. Generally, right? So things like vSAN would fall into that in that example. Distributed vSwitch would be an example of the data plane of networking being implemented in software. Does that make sense to everybody? Right? And then the last thing, the third principle, is program everything. So in other words, automate through programmable APIs. And the why behind it are fundamentally these three things: to reduce fragility, to increase the agility, to be able to automate. These are real reasons. This is not marketing hyperbole. In fact, data plane and control planes are terms that only engineering would use, because a normal customer goes, what the hell are you talking about, right? Now, the thing that's important to understand here is this is a market that is rapidly accelerating. So who here is using vSAN? How's it going? PJ? What version are you using, if you don't mind me asking? 6.1, so the most recent version. Huge improvements, by the way, from 1.0 to 6.0 to 6.1. There was another hand in the back that went up. How's it going? So? Yeah. Big improvements. And by the way, I'd get in trouble from Duncan and from everybody else. Wait till you see what's coming in the future vSAN release train. It's incredible, right? But it's still early days. Again, for perspective, roughly 2,000, let's call it 2,500 customers. Anyone here a VNX customer? Thank you for being VNX customers, by the way. By the way, notice that some people raise their hand for both things. It's not necessarily an either or, right? For relative size and scope, the VNX business is roughly around 200,000 VNXs deployed. Again, I'm not making a value judgment of good or bad. It's early days in SDS. Anyone here a Scale.io customer, out of curiosity? So Scale.io is like vSAN, is an SDS data plane. And very often we were finding that basically the EMC teams and the VMware teams were basically arguing over which SDS is better. And what we've realized as two companies, as partners, is actually this use is pretty simple and clear. For you, again, PJ, what do you like about vSAN? Mm-hmm. Hyper-integrated. There is nothing more integrated with vSphere than vSAN. That behavior, and by the way, this has nothing to do with its performance or its scaling. It can scale to a ton of use cases. But the behavior around simplicity and ultra integration means that vSAN is a no-brainer for customers considering SDS, where they're relatively homogeneous on vSphere, and they're focused on simplicity as one of the primary drivers. Conversely, we find other customers who are like, no, I need to have an SDS plane that I could use for vSphere, but I also need to be able to use it for this physical Oracle host here. We, of course, would say, hey, you should virtualize that Oracle host, but sometimes they don't. Or other physical hosts, and in some cases they have different hypervisors in use. In other words, they're a much more complex, heterogeneous environment. And that's the place where Scale.io sings, right? What we've done here that's interesting is between the two companies, we basically have just launched a new thing where basically a customer that is in the middle, they're thinking about what do I use in my enterprise data center, and I'm not sure, do I want to go one way or the other? We've made it really simple. You can basically buy one and get both, and then you decide over time which one you want to use. Because in general, what we're finding is people have mixed use cases outside the very clear black and white swim lanes. Service providers really tend to lean towards Scale.io due to scale and heterogeneity. Smaller customers really lean into vSAN because of its simplicity. Again, that's not an implication that vSAN does not scale. It's rather that its greatest strength is strongest in those use cases, right? And basically what that means is that in the middle part of the market, we want to make it really simple for everybody to start to use SDS because you should. It's good, right? It's early days, but rapidly accelerating. Now, I'm going to skip some of this stuff because I'm going to run out of time, and probably how many of you were in Duncan's session on vSAN? Long and short of it, vSAN equals awesome. By the way, Scale.io is also awesome. And the last thing that I would say on this SDS topic is the most beautiful part, in my opinion, is you can say, Chad, I think you're full of it. How would you say full of shit in Italian? No, no one wants to tell me? No, everyone's like, I'm being recorded here on camera. The best part of SDS is that you don't have to listen. You don't have to sit through a PowerPoint. You don't have to listen to the sales rep and the SC explain to you why it's great and better than X or Y. You can just try it, right? So all of the links here, so the first link will take you to the vSAN downloads. If you go to GetScale.io off VMC.com, you can download it. And by the way, at EMC, we've made everything that we make software freely and frictionlessly available. This is a thing where I'd encourage you guys to prove me right. The product team said, oh my goodness, if we do this, customers will never actually use it. They'll be afraid, they won't, and they might defer how they acquire technology. And I'm like, no, let's be brave and bold and just say, if the technology is good and we make it really easy for people to try, they'll come to their own conclusions. I think that would be great, right? So go, download, use. The thing that I'll tell you that's interesting is on the Scale.io side, on the ECS side, on the Viper side, they have no time bomb. They have no feature or function limit. They have no capacity limit. Our biggest Scale.io customer in the world has 18 petabytes of Scale.io deployed, and it replaced 200 VNXs, mostly behind vSphere use cases. This is a really big customer, right? You could get the exact same software that they are using and deploy 18 petabytes of it if you want, without talking to an EMC salesperson or a partner salesperson. Now, it's not supported, right? It's community support, right? If you want to deploy it in production, you should obviously license and buy it. But the point is, SDS allows you to try and learn. Now, the question that then comes up to me about the debate is everything SDS, right? And you know, in the Pernix fellow that was here, I think his name was Frank, great presentation. He ends with the I love SAN, and Pernix makes SAN better, right? And, you know, Duncan, I wasn't here for the presentation where he was making fun of me, you know, for the fridge with the array in it. You know, there's SAN huggers, and everything should go software. Right, Duncan? Everything's software, right? So in these, people are passionate and focused on the areas that they focus on, right? That's natural and normal. So I'm going to go way off of script here, and I'm going to try, again, this technology that's likely to crash. The answer is everything SDS, and the answer is no. So this is the entire storage world, okay? There's a world dominated by things like Vmaxes and HDS and 3PAR that people have characterized classically as a Tier 1 SAN, right? Supports the most mission-critical workloads, has deep replication technologies that are crazy. I've got an Oracle database that I need to replicate between 3 locations with a 0 RPO. It's 200 terabytes of data that needs to get replicated every 5 minutes. And I have 1,000 LUNs that all need to be replicated synchronously, all in consistency. Right? That's that sort of market that is that stuff. And again, if this sounds strange and foreign, every time you make a phone call, you depend on that sort of system. Every time you withdraw money from a bank, you're depending on that sort of system, right? So even though you may not think, hey, this isn't me, that's okay, right? But those exist. That circle is about $20 billion in size, okay? Whole market here, right? This circle is shrinking. No one knows exactly how long it's going to take to shrink, but it's shrinking at roughly 7% per year. Very scary for people that's all they do, right? Because you don't want to operate in that market, right? I suspect, this is my personal opinion, that eventually this circle will shrink to a circle that's about 6 billion in size. I don't know how long, but I think it's going to shrink to about that size. What will be left inside that circle? The only thing that will be left will be the workloads that absolutely need those behaviors. And mainframe. So it'll be mainframe and massive, very fragile classic applications. Very important, right? And they're not going to get replatformed. So where is all the rest of it going? The biggest trend out of this circle is towards all-flash arrays, not SDS. And the reason for this is that many people have put workloads on classic Tier 1 systems for latency and performance reasons based on caches, right? And so they look at very flat performance linearity and some enterprise data services. This is the bulk of the exodus. Does it make sense? The next biggest exodus, not quite as big, so it's a smaller arrow. This is very strange, is towards SaaS. So today, many of those workloads that sit on that sort of stuff sit on VMware, on something like a VMAX, but it's like a CRM system. And in the future, the customer says, I don't want a CRM system, I want to use Salesforce.com. I currently use Exchange. I'm not going to use Exchange, I'm going to use Office 365, right? All of that trend is workloads leaving. By the way, at Salesforce.com, they still land on a VMAX, but behind the scenes, right? But the point is that means that workload disappears from you as a VMware customer, in a sense. Does that make sense? And the smallest exodus is towards cloud-native apps. In other words, where someone goes, that classic system that we used to run that would sit on Oracle, forget that. I'm going to completely move it to Cassandra distributed database, blah, 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 blah. And then it doesn't sit on VMware very often, and it doesn't sit on a SAN at all. Does that make sense? So this is the picture of what's going on here. Then you've got the world of Tier 2 block. This is transactional systems, meaning things that deliver low latency, that are lower dollar per gig. The world dominated by VNXs and NetApp FAS platforms, and then new entrants, right? That you see, Tintry, Nimble, those sorts of things, right? What's occurring here is that this circle is also shrinking. In fact, this circle is shrinking at around negative 15% per annum. Really crazy, crazy stuff. So the question is, will this circle eventually shrink and then stop? Answer, in my opinion, is yes. It'll shrink to a circle that's about 5 billion in size. And you know what this will be typified by? Customers who need something that is very, very small. So in other words, if you need to have something that is in a $10,000 price band, right? Very small. Call it, 50 terabytes of capacity, 100,000 IOPS. It is very difficult to beat the economics of a small two-headed cluster. And invariably, SDS models are better as they scale bigger. Does that make sense to everybody? So the biggest exodus of this is a tie between hyper-converged infrastructure appliances, right, which would include things like vSAN-ready nodes and vSpecs Blue and Nutanix and SimpliVity and all of that stuff. Another category called hyper-converged rack scale systems. Hang on. Phew, right? There's another big exodus towards things. All-flash arrays have a disruptive effect here. battles being fought furiously in the marketplace that you guys can see playing out. And then the last one is SDS plus what I call COTS, commodity off-the-shelf hardware. You assemble. This is an example where you just say, I'm not going to get a vSAN ready node, I'm not going to get a hyper-converged appliance, I'm just going to use vSAN or Scale IO and buy my own hardware. Does that make sense? Now, the thing that is fascinating in this is where is the information growth occurring? Most of this actually isn't net new workload growth. And as VMware audiences, we tend to think that VMware is the center of the universe, right? The bulk of the information growth isn't even in the world of NAS. This is a circle that's growing at about 20% per annum, right? Anyone here use Spotify? Anyone here use Xbox Live? If you use any of those and many other online streaming services, you are, although you don't know it, an Isilon customer, right? So there's a big scale-out NAS thing behind the scenes that's storing all of that stuff. The biggest single Isilon purchase ever was from a customer in Q1 that bought 100 petabytes at one time, right? You can imagine the sales team was dancing in the street, right? Immediately the customer said, we love it, technology works great, but by the way, we're never going to buy another one again. And we were like, what? You said that we were great. And they said, because unless it can run on open compute hardware, you're forcing us to build our own scale-out NAS stack, right? So what's the answer? We'll build you a just software-only Isilon stack, right? So in Q1, there will be a version of the Isilon software that you can run on anything, on VMware, on bare metal hardware, whatever, right? The number of customers, however, for whom that makes sense is like 5. Everyone thinks they're like Facebook or thinks that they're like Amazon or Azure. I hate to break it to you, you're not, right? You can leverage some of the great technologies and learnings and ideas that come from those places, but you are different. You do not have a bare metal as a service function in your enterprise, right? The biggest circle, however, that's growing like crazy is this one. This is growing at like 100% per annum. Giant object and HDFS stores, and by the way, you guys are all proving it to me right now. When you take a picture, if you're using an iOS device, if you're using iCloud, it immediately gets synchronized to iCloud, right? That's not sitting on transactional storage or NAS. It's sitting on an object store so massive you can't even imagine it, right? And the largest HDFS stores in the world are likewise not measured in hundreds of terabytes or even petabytes, but in terms of exabytes, right? So the question is like, is SDS the only thing in the universe? No. Clearly, there's huge action going on in AFA land, in all-flash array land, right? And when you think SDS, you think vSAN, Scale IO, or packaged into Hyper-Converged. There's a whole other world of SDS happening in these other areas. I hope this is useful and interesting. That creates an important segue towards all-flash arrays. I always am loath to make any presentation that we make a commercial. So I'm not going to spend a lot of time on this. But we think that if you look at this slide here, if you put yourself into EMC shoes, winning the all-flash array battle is really important, right? Because the workloads are moving, right? Winning the SDS battle, really important with VMware and with EMC. So we have to do those things because it's very important to our overall business. So Extreme IO, important to understand. Any Extreme IO customers here in the room, just out of curiosity? How's it going? Really good? Good, thank you. Another, very good? By the way, in general, that's what I hear as feedback, really good. The reason that it's really good is very basic. Our point of view is that with NAND as the only persistence model, and by the way, this isn't only in AFAs. As Duncan said, huge trend towards all-flash vSAN configs. Our biggest Scale IO customers don't use a lot of magnetic media. They use almost giant pools of NAND for almost everything, right? Obviously we want to use NAND, we want it to go fast, right? Deliver lower latency in a very predictable way. But the other thing is to try to use all-flash and new white sheet designs to do things better or smarter. And our point of view, and this triggered the initial investment into Extreme.io many, many moons ago. Behind the scenes, if you want to hear the coolest podcast ever, go to the Hot Aisle and download and listen to episode 8. And I can't believe that the guy who talked about it actually did it on the record. He's the guy who runs our venture firm. So we have a venture capital firm within EMC that invests in startups, because it's very important to stay on top of, like, hey, what's going on? And he disclosed like way more than I would have expected that he would do on a podcast. But if you want to get an insight into how big companies, not just us, but Cisco, Intel, others are using venture funding to create a new form of innovation, it's really interesting. So we invested in these guys a long time ago. I won't give you the exact day, but many years before we acquired them. And the reason we invested in them is we said we think that all-flash arrays will bias, it's not the only answer, will bias towards scale-out architectural models. And that the key architectural thing is the ability to scale up through many, many controllers. So today, we can scale up to a total of 16 brains. They're all industry standard servers, so you could call this SDS in a sense, but that's a huge stretch. The reason it's a huge stretch is the only software-hardware combination that's allowed is the one that you buy from us together, right? So it's not very software-defined. Why is that? It's because it has an architecture that tightly couples all of the nodes where latency between nodes is very, very sensitive. Why? It's because of this second point. In Extreme.io, the thing that it does that's really cool is all of the metadata. And metadata is always used in all storage subsystems for any operation which is a data service, a copy, a replica, a data reduction service, those sorts of things. All of that is stored inside the RAM of the systems. This is a strength and a weakness, actually, of Extreme.io. In a scale-up system, you can add more capacity of NAND without needing to add more RAM, right? So there's pros and cons to any engineering design. Our point of view is that you want to keep the metadata in RAM because that determines very, very linear behavior always, under all behaviors, all services, all nodes. And by keeping it all in RAM, it means that the behavior is very, very linear. It does mean that there's a maximum amount of NAND that a single XBrick can address. Does that make sense? So that's the trade-off. Anyone who says that there's not a trade-off in any engineering design is smoking something, right? So, and by making that all be in memory all the time as the cluster scales out, very linear performance and very balanced system-level behavior. The other thing is that it makes things like any copy operation work extremely well. So when you do a VAI, in general, the storage industry has done a pretty good job of all of us complying with VAI, and vVol's coming along now. Everybody's jumping into the vVol wave, which is great. That's VMware driving standardization in the industry. Not everybody's implementation is always the same. So one thing that's very cool about Extreme.io, and here I'm not going to compare it against the competition. I'll compare it against the VNX, or I'll compare it against the VMAX, where the metadata isn't always in memory. In the case of an Extreme.io scenario, there is never a back-end operation. There's no back-end copy ever, because all of the data is basically fingerprinted by its content. So if the content is the same, the only thing that's ever changing is metadata. But since the metadata is always in RAM, there's never a time period where there's a metadata dump to an SSD or to, God forbid, a magnetic media type. Anyone here using a VNX with dedupe? Have you noticed that when the write workload is not that high, performance is really good, but when then write IOPS go really high, the dedupe performance takes much longer and in some cases slows down the I/O materially. The reason why that is occurring is because the metadata rate of change is happening fast enough that it can't be stored in the RAM of the system, and it's actually getting destaged into an SSD. This is a real-world manifestation of this thing I'm describing. Does that make sense? By the way, if you haven't updated to the latest version of the software bits, huge improvements in dedupe performance. Just as a okay. So the other thing that I think is cool is we've integrated we think that everything we do needs to integrate to vCenter. So there's great plugins for vCenter integration. There's great integration with the vRealize operations suite. There's great integration with open APIs that can be used to automate all sorts of workloads. And it's integrated with our open SDS control plane abstraction, which is called Viper, right? I want to show you guys something a little funky here. Pull out your phones. Do I have my phone on me? So what this is the GitHub repo of all of our open source projects. So if you go and you take a look, on there, one of the ones that's right at the top is something called Copperhead. Copperhead is the open source trunk of the Viper controller. So if you want to basically, if the Viper controller doesn't have a feature that you want, you can actually build it yourself. This sounds weird and strange, but we're now at the point where actually in the next Viper release, there are 5 major features that came from Intel, SAP, Citi, and several universities. So it's this really weird new world of like open source trunk, you know, enterprise distribution software is showing up in interesting places. By the way, there's some other interesting stuff on there I'm going to point out in a little bit as well. There's deep integration with SRM. 5 minutes? Holy smokes. Okay, I'm going to keep moving here because I'm going to run out of time. It powers VMware's internal OneCloud that is used for their internal private cloud XtremIO. It powers the hands-on labs at VMworld. So if you go and you check that out, all good examples. Next topic of debate, hyper-converged. Our point of view on this is that there's actually no difference at the macro level between converged and hyper-converged. That sounds strange, but first thing you need to understand is what is the purpose of converged infrastructure? It's to consume compute, memory, network, and storage as a single unit. There's different ways of achieving that, and those different ways of achieving it have different pros and cons. That earlier discussion, anyone that says one way all the time under all circumstances, you remember that, right? So we started this effort around vBlock and the idea of block scale architectures. These things are great so long as you want them in any size you want, as long as that size is big, right? The smallest vBlock is about 40U. Its sweet spot economically is when you have 2,000 VMs or more, right? Why? It's because it's built out of traditional storage, networking, assembled into a converged infrastructure stack. For many customers, by the way, that is perfect, and this is a $2.5 billion a year business and growing like crazy, right? So again, you see lots of like FUD and darts thrown, what's converged, what's not. This is one form of converged infrastructure, in our point of view. The other form is what we would call an appliance form. Now, an appliance form instead uses an industry standard server, and it uses an SDS layer, a software-defined storage layer that's distributed, and it uses a management and orchestration stack to turn it into an appliance, to update, maintain, et cetera, et cetera. And I'm sure lots of sessions and breakouts, you got lots of advertisements over why one hyper-converged appliance is better than another and so on and so forth, right? The sweet spot of these things is small and simple. The reason that small and simple is their sweet spot isn't because they can't scale. It's because trying to design something that's really, really simple, you focus on simplicity first and foremost. The other thing is that they can start at much smaller scale points, 100 VMs or less. So very popular for customers that our SMB customers, small, medium enterprises, robo and enterprise, et cetera, et cetera. In our point of view, we've launched our first product on this. It's been on the market now for roughly about a year, which is built off of the Evo Rail program, and it's called vSpecs Blue. It's simple, it's easy, it's turnkey, it uses the software from VMware, it uses vSAN, and we added the ability to do remote replication at large scale, to add at no extra cost 10 terabytes of object storage from a cloud object store, ability to do enhanced backup recovery, and tie it into the EMC support systems, right? Our view is that when you're buying this, you want an appliance soup to nuts. Now, without giving things away, and I'm cognizant of the fact that I'm short on time and on camera, we have very exciting updates coming up in this category space. This is a market that we feel is going to be very important, and we're in it to win it. So stay tuned. Lots of exciting stuff to come from VMware and from EMC together. Now, we've come to the conclusion that there's something in the middle. And the something in the middle we would call a rack scale architecture. Now the difference is this still uses an industry standard server with an SDS layer and a management and orchestration stack. The difference, however, is the following. This isn't designed to start small. It's designed to scale big. Those are not the same, right? So this won't start at 2U or 1U and, less than 50K. This thing will start at like 200K and, be 8U to start. But you would be able to scale it to literally hundreds, and in some cases even thousands of nodes, being able to support millions and millions and millions of VMs, right? So it's a different design center, right? Again, think about it. In this rack scale system, you'd also need to be what we would call disaggregated, which means that you need to be able to scale compute, storage, and network in a very disconnected way. Do you think if you were going to design a system like this, the top of rack switches would matter? You bet they would, right? If you're scaling like 8 nodes or 16 nodes in a cluster, use whatever 10 gig switch you want. But holy smokes, if your SDS is spanning 1,000 nodes, you have to think about the spine leaf topology and the SDN layer as part of the design. So hint, hint, if someone says this can scale to infinity and beyond, and then says, use whatever network you want, okay? So, in our point of view, the VX Rack is now in what we would call directed availability, meaning it's out there, customers are buying and deploying, but we're always careful about when we GA something as a big company, immediately there will be thousands of customers all over the place. You have to manage that very carefully, right? So it consists of these various components. You can have it in a broad range of hardware configurations, dense compute, dense memory, dense storage configurations. They can all vary. And inside a scaled out disaggregated configuration, they can be all over the map. Now imagine what this would mean. Would you need to have a very sophisticated hardware automation and abstraction layer in this? Much more sophisticated than in an appliance, where you have maybe 5 or 6 different node types. Here you have like all sorts of different node types. And you got to think about that networking domain, right? The point being that the management and orchestration stacks are much more sophisticated inside this domain, and they have to be heterogeneous. There will be some customers who are like, man, I'm all in on VMware, and I want the Evo SDDC suite. And we say, great. Put it on top of a VX rack, deploy it this way. There'll be others that will say, I want some of that, but I also want some of something else, Mesos or Kubernetes or OpenStack on KVM or whatever. Or I just want bare metal. And maybe I want to shift those percentages over time as how I'm using them. Very different than an appliance use case. Does that make sense? So this is what the UI looks like. Again, this is where the graphics card on this thing is just literally going to lose its mind. So when you log in, you see the system and system state. There's the concept of tenants. So you could have multiple tenants even at the hardware abstraction layer, even before you put on an SDDC stack, right? Within that, you can also have a heterogeneous set of deployments. So there you can see we've got, something that would basically power an Evo SDDC stack. It might be a little bit of something else. And here we've rolled in a new rack to add to the cluster, and we've just discovered it. So by the way, that means that there's got to be a hardware management and orchestration stack that can discover networks, switches, servers, a lot of ingredients, right? Again, notice how I'm highlighting. People think these two ideas of rack scale hyper-converged and hyper-converged appliances are the same thing because they're built out of industry standard components and SDS. They're wildly different architecturally. Okay, I'm going to skip this, again, in the spirit of time. We have not announced this yet. We're not going to announce this until December the 1st. But what the hell? I'm here in Milan. I'll tell you about it. In creating this, we were like, holy smokes, we really need like Pixie Boot to work right. Oh no, Pixie Boot works totally different on all of these different server vendors, right? IPMI is totally inconsistent across, it works so long as you're all Dell or all HP and you use their tool. But by the way, it doesn't touch the networking domain at all. We're like, well, what about this Project Ironic thing that's going on in OpenStack? And we're like, oh, it's not quite there yet. And then we were like, we've got a problem internally as well. Like when a customer has 1,000 node Isilon cluster and you have to update this firmware, that sucks, right? So we've been working on something quietly for about a year, and we just open sourced it, called Rack HD. It is our goal to make this an open standard about low-level hardware abstraction and automation. So if you go to that GitHub, emccode.github.io, you can download it. You could actually start to use it tomorrow if you want. You could contribute. We've had loads of customers going, oh, you're solving a problem for me. Facebook, Azure, AWS, they have people that have built their own versions of this idea internally. We're trying to make it something that now is available for everybody to go off and use. Does it make sense? Really, really freaking cool. This is below Puppet, below Chef, below Ansible, way before vSphere boots, et cetera, et cetera. Okay, I'm going to try to wrap super fast. Okay. We're the last session of the day, though, right? Yeah, all right, fantastic. So remember that this is debated topics. SDS we discussed, is SDS cool? Yes. Is it everything? No. Hyper-converged, is the hyper-converged the answer? No, the hyper-converged thing isn't the answer for everything. Are they all the same? No, they're not. The way to think about the appliance and rack scale is this observation. Core differences. One is focused on simplicity and start small. The other one is focused on rack scale, scale big. One uses very common building blocks, right? They can have a little bit of variation. The other one is like, whoop, all over. Can have lots of variation. This use any switch versus no, networking needs to be part of the system design, right? I'm not saying that it's built on proprietary switching ingredients, but you have to think about the switch design as part of the system design. And then you've got this lightweight management and orchestration versus heavyweight. Last thing, cloud native. Did anyone sit in on the cloud native session that was going on in the other room over there? It seemed really good. It was in Italian. I could not understand a word. But the fellow that was presenting from VMware was doing a good job. What the hell is this cloud native stuff? I'm going to skip this session in respect of my colleagues in the panel. Or do you want me to keep going, Duncan? I'll do it super short. Oh, boy. Yeah. So the reason this is important for me to talk to you is cloud native in even the most sophisticated enterprises, the most advanced enterprises, is like 5% of their workloads. Almost all of their workloads are not cloud native. And the test of is your application cloud native or not is, one way of saying it is, can I walk into the data center and just randomly unplug 20% of the cables? If the answer is, what are you thinking? That would be crazy. Your applications are fragile. Your applications are not cloud native. They need backup and DR and resilience. They need VMHA, right? If your application says, I don't care, I will just elastically and automatically scale out as needed, then it's a cloud-native app. The reason that this is important for us is all of you have led the wave of server virtualization and now storage virtualization and now networking virtualization. There's an opportunity for you as humans to lead the wave here in Italy on this new way of building applications and infrastructure stacks. It is as radical, perhaps more radical, more disruptive than the shift to virtualization. It's in its earliest days. If some of you are wondering like, oh, I wish I could have been at that first VMUG, 10 years ago before everyone knew that VMware was awesome. If you want to do that, you have an opportunity now because this is at that same stage. Does that make sense? So I'm going to completely skip this just because there's not enough time, but there's some really cool stuff. Maybe what I'll do is I'll do like a recording and I'll YouTube it. And if anyone's interested, you can just follow it on my blog. But lots of stuff, lots of new ideas to interpret. There's a Virtual Geek post. So if you just Google Virtual Geek Cloud Native, it'll probably be the #1 hit. And very cool stuff. There's some stuff that we're working on here. If I just basically skip to the end of this, hang on. Boop. I will discard my annotations. There's some stuff that we're doing which is really, really cool. So our point of view on this cloud native stuff is it's generally designed to be deployed at very large scale. So you've seen what we're doing with VX Rack and that you've got pools of compute, network, and storage, and you've seen that Rack HD thing, which basically can pool and automate it. You could deploy Photon platform directly on top of this. You could deploy OpenStack on top of this. You could deploy Mesos or Kubernetes directly on top of this. You could even deploy Cloud Foundry right on top of this. But we're thinking that there might be many customers who instead say, I need to have a thing that abstracts even those. So we've developed something that is currently in directed availability and will GA in January called the Neutrino infrastructure layer. And it's not a coincidence that Neutrino and Photon are similar subatomic particles, right? The Neutrino layer is designed to underpin an OpenStack deployment, a Hadoop deployment, or a Spark deployment, maybe something that's going to be deployed on top of bare metal, and of course the Photon platform from VMware, right? And the observation here is people want to use things like Cloud Foundry, which is a structured PaaS layer on top of these models. What they need is they need the ability to elastically move them up or down over time, and that's what the Neutrino platform does. So, in closing, you can see that I had no shot in hell of getting through this. If there's 5 takeaways to take away from this session, the first one would be the following. SDS is here. So anyone who says SDS is not ready or bad or whatever, I would ignore them. SDS is here, it's now, it works. It's still early days, and anyone who says it's the only way, I would tend to ignore. Hyper-Converged is a real system architecture, but I vehemently personally disagree with the idea that something that can be simple and small can also simultaneously scale to infinity and beyond. I think that it's important for us to focus on outcomes and not hype, right? So all of these different converged models will, in my opinion, over time start to be how we consume stuff, but it's not going to be one way or the other way. It's going to be multiple ways. Cloud native is different, totally different. It's alien. It's like learning a new language. It's different at the app layer, it's different at the IaaS layer, it's different at the operational layer. And that leads to this last thing that is important, which is that I'm finding that the winning strategy is to treat Platform 1 workloads like mainframes and treat them in one universe. To treat Platform 2 workloads that depend on infrastructure resilience as one other universe, and to treat cloud native worlds as a third universe. You can deploy Cloud Foundry on vSphere. It works great. It's actually the #1 way that Cloud Foundry is currently deployed by count. I think that over time, more and more people will deploy things like Cloud Foundry on the Photon platform rather than on vSphere because there's inherent advantages to treating P3 like P3. So thank you. Very much appreciated. My apologies for running over time. And shall we segue to the panel?